Good morning, children. Today we are here to discuss Unit 8 floating bodies of 9th class. Within this particular class, we are going to discuss about pressure of air. Pressure of air is also called as atmospheric pressure. What is atmospheric pressure? If I take a ball consisting of mercury, take a U-tube, then itself within that add completely filled up with what? Mercury, and just shake it up vigorously so that what, if any air bubbles are existing, they can be evacuated from that one, and completely fill it up and immerse it in a ball consisting of mercury. As you place it up, we will get certain area. So we will get certain area. Within this particular area, air column will be existing. Atmospheric pressure can be defined as the weight of air column. Weight is nothing but what we have force exerting by air in this particular air column, containing a unit area. It is existing there itself, containing a unit area from the mean sea levels. From sea level, it is having that particular unit normal area to the top of atmosphere. To the top of atmosphere, unit normal area which is containing from the from below of sea level, from the mean of sea level, if to the top of atmosphere, if it is existing, that one, we'll call it as nothing but what? Atmospheric pressure. These atmospheric pressure can be measured as what? Force per unit area. And the units to measure it is nothing but what? Millibar or MB, small m, small b, it will be there. In application level, if you are applying this particular atmospheric pressure, at that particular point, we will measure it as what? Kilopascals. Kilopascals we can measure it up. This particular atmospheric pressure can be measured by certain devices called as, one is aneroid barometer, other one is mercury barometer. Aneroid barometer doesn't consisting of any liquid, but whereas mercury barometer consisting of a liquid called as mercury. This is general definition about atmospheric pressure and how it can be get measured, units, as well as application level, how it with what unit can be get measured, and by using what devices we can measure atmospheric pressure, we can identify that one. Coming to next one is what? Activity 7. What does this activity 7 gives us here? Observing air pressure here. It gives information about observing air pressure. We will observe that there is existing of certain air pressure. To perform this particular activity, we require three different devices. One is a beaker is required, other one is a glass is required, third one is what? Cotton is required, fourth one is what? Water is required. By using these four articles, we can observe how this particular air pressure can be exist. So take a beaker, fill it up to 3/4 with water. After filling up with 3/4 with water, take a glass. Inside this particular glass, fix some cotton there itself, and place inversely over that particular glass inversely, and dip into this particular beaker till it touches the bottom of that particular beaker. Place it in that particular way, and observe the cotton bottles are placed up inside here. Whether it become wet or not, just to observe it itself. If you observe, you will find that the cotton which is existing inside this particular glass will be remain as dry only. Why? Why it will be remain dry means what? There within this particular region there will be it is filled up with what? Air there itself. As I am inverting and placing it also, air molecules will get existing within that one. So that as I am keeping that air applies force of air which is applied on water. So what happens? The air which is existing inside applies certain force on water molecules by the air present in this particular tumbler. In tumbler, air is existing. That air exerts pressure on what? On water molecule. So that what happens? That force doesn't allow a water molecule to enter into it. Due to that reason, it is having water. The cotton which is placed inside is what? Is in dry state only. It is existing. By this we understood that force which what? Within this era there is exerting force. Within that era there is certain force. Due to that force, what happens there itself? Force on unit area of water. Of water is nothing but what? Pressure of air or atmospheric pressure. We can call it what we have defined here. That is regarding observing of air pressure, how it will be existing by using activity-7. We have did it up. Coming to our formulation, how to formulate this particular atmospheric pressure. Atmospheric pressure is equal to one formula is there. What is that one? Rho into H into G, where rho indicates average density of atmosphere. H indicates height of that particular molecule, height. G indicates acceleration due to gravity. Formulate that particular one. How we can make a formula, how we can derive a formula from the definition of atmospheric pressure. We have already studied the definition of atmospheric pressure here, and all the objects on one point we have to keep in our mind, that is nothing but what? All the points, all the objects on surface of earth are subjected to constant atmospheric pressure. There won't be any variation in atmospheric pressure whatever the objects are existing on the surface of the earth. Constant atmospheric pressure will be there. Therefore, I am taking definition. Atmospheric pressure, ATM indicates nothing but what? Anytime money what it is atmospheric pressure. Short form of atmosphere I have given there. Atmospheric pressure is equal to, it can be defined as force exerting on atmosphere to the top surface area of the earth. Here also force per unit area is the formula there. Force of atmosphere by surface area, which surface is existing on the surface of the earth, it is existing, therefore surface area of earth I have taken there. But according to Newton's second law, we know that force is equal to mass into acceleration. If this formula is subjected to gravity, if I am subjecting this particular to gravitation there, what happens there? Acceleration will be changed to what? Acceleration due to gravity. Therefore, W is equal to mg, we will get the formula. Force can also be equalized to what? Weight of the atmosphere there. Weight is equal to mg, F is equal to mg also, it becomes that itself. Therefore, force of atmosphere can be represented as what? Weight of atmosphere by surface area of the earth, we can take it up. But we know that weight of atmosphere is equal to how much? Mass of atmosphere into acceleration due to gravity. Therefore, mass of atmosphere into acceleration due to gravity are taken here by surface area of the earth. If I go for mass of atmosphere, from which I can derive this one? Density is equal to mass per volume. I require not only mass. Therefore what? Multiply. Density into volume is equal to what? Mass. Therefore, here density means what? Average density of atmosphere. Density means what here? Average density of atmosphere into volume of atmosphere into acceleration due to gravity. That is, density into volume is equal to mass. Mass of atmosphere can be represented as what? Density, average density of atmosphere into volume of atmosphere into acceleration due to gravity. But we know that average density of atmosphere can be represented as what? Pro symbol. I am taking pro symbol. Now coming to volume. If I go for volume, if I am taking any block here, any wooden block in which three-dimensional length, breadth as well as height is existing. How we can calculate volume? Volume is equal to surface area of this particular length into breadth into height. I have to multiply. Therefore, this is called as length into breadth is called as what? Area. Therefore, surface area of the earth, as we are talking about earth, surface area of earth into height, at what height it is existing. Therefore, surface area, rho into surface area of the earth into height will give us about what? Volume of atmosphere. Volume of atmosphere into G, where G is called as acceleration due to gravity. Surface area of the earth, height of the earth we have taken there itself, therefore it will remain as what actually have taken there. Therefore, atmospheric pressure will be equal to rho into height into acceleration due to gravity on the surface of the earth. If there is existing of any object, it will have constant atmospheric pressure. This is the concept about atmospheric pressure or pressure of air, and how we can formulate this particular formula. Try to analyze this particular formula. Try to take force means what? Mass into acceleration according to second law. But we know that force is equal to, if I am applying to gravitation, force is equal to ma. A becomes as what? G, acceleration due to gravity. Therefore, mg is nothing but what? W is equal to mg. Force exerted by body is equal to nothing but mass into acceleration due to gravity. Therefore, force is converted to weight. Later on, weight we have a formula, mass into acceleration due to gravity. This indicates mass and acceleration due to gravity. But this mass is nothing but what? From density formula. Mass per unit volume. Density into volume is equal to mass. Therefore, in place of mass, I am keeping this is density and this is volume. Average density of atmosphere into volume of atmosphere into acceleration due to gravity. But density is represented with what? Pro symbol. Volume, how it can represent? Volume is nothing but what? If I am taking three-dimensional figure, this total will represent what? Area, length into breadth, and height is there. L into B into H. Therefore, what happened? H must be surface area into H if I multiply. Surface area of the earth into height will give us nothing but what? Volume. Therefore, surface area get cancelled. Height into acceleration due to gravity into rho will be remain. Therefore, it is called as atmospheric pressure. It is on the surface of the earth, rho into H into G. By this we have completed pressure on air. In next class we will discuss how to calculate the particular atmospheric pressure. Thank you, children.